Hello students, welcome back. So now we are going to be doing bivariate analysis. So bivariate means two variables. In this particular session, I'll be focusing on numerical versus categorical. So first I'm importing my pandas. I'm also importing these libraries. These are for visualization. So in this case, I'm reading my CSV file. In this case, my CSV file is data underscore mpg.csv, and I want to print out first 10 samples of my data. So just to get a feel of my data, just to identify my numerical and categorical columns. So in this case, you can see that your cylinders like 8484. Okay, this seems like a categorical. And then look at this other values. Then you have model year 72, 72. These are categorical. Origin, that's another categorical. And name, this appears to be a categorical. And these columns right here, displacement, horsepower, weight, they seem to be more like numerical in nature. Okay, we can also check for categorical and categorical column using info. So any column that are float and int, they are indicators of numerical column. So in this case, when I run this info with memory usage deep, that also gives me the memory usage, by the way. And also you can see that anytime when you see columns like int64, they tend to be a good indicator of categorical values. Float 64 generally, through my experience, I've very rarely seen them as categorical. Generally, they tend to be numerical in nature. And now let's identify our categorical and numerical columns. So identifying your categorical columns is a little bit easier. Step one, first you identify number of unique values in each column. So in this case, I'm printing df.nUnique. This will give me the unique value for each column. For miles per gallon, there are 129 unique values. For cylinder, there is a 5, displacement 82, and so on and so forth. So based on the count, based on these counts right here, it seems that cylinder, like if you look over here, there are only 5 unique values for cylinder, and then for origin there are only 3 of them. For model year, there's only 13. So that tells me that it seems like cylinder, model year, and origin, they are like categorical. Let's see their unique values. I want to see how many different values are there in the cylinder, how many different values are model year, and how many different values are in origin. So when I run this, it gives me for cylinder, these are my values, 8, 4, 6, 3, 5. So for cylinder, there were like total 5 different values, and these are my 5 values. For model year, these are like 70, 71, 72, 73, all the way to 82. So how many model years are there? Total 13, and these are my 13 values. Well, for origin, there are 3 values, and you can see that for origin right here, when I print out unique, it gives me USA, Japan, and Europe. These are my 3 values. So conclusion, your categorical columns would be origin, cylinder, and model year. That's the one I'll be choosing. For numerical, I'll be choosing MPG, displacement, horsepower, weight, and acceleration going forward. So let's do the box plot first. So in this particular instance, I'm actually setting my palette and also my font for the title and labels. This particular part, by the way, is optional. I just want my background to be dark. That's why I'm using this. And I want the colors to be gold. That's why I'm using this. Okay, you can actually skip this part if you want to. Okay, step one. So let's plot our categorical columns. In this case, I'm doing MPG versus origin. So my MPG is my numerical and my origin is my categorical. So column equal to origin, and I'm doing my box plot. I'm specifying my data frame, specifying my X value and my Y value. When I plot that, this gives me the miles per gallon for origin. Let me decrease the size of the screen so you can see that. So in this case, you can see that for origin, there is a USA, Japan, and Europe. And the miles per gallon, this is the box plot from my MPG. And you can see that for USA, the MPG goes from here to here. Most of my data lies in this region. For USA, most of the cars, their miles per gallon is between 15 to, I would say, 23, 24. For Japan, most of the cars, their miles per gallon, they go from 26 to maybe 32 or something like that. And same thing you can derive for the Europe. So observation is this. Let me increase the size of the screen so you can see now. So Japanese car, they generally have a higher MPG. You can see that Japanese car are over here, and you can see that they have a higher MPG. Okay, and then US car have a lower MPG on average. You can also see that your US cars are in this range from 15 to this number, Japanese car and this range to this range. So US cars are lower, Japanese cars have a higher MPG. And now I'm going to do MPG versus origin, MPG versus cylinder, MPG versus model year. This is my numerical, and these right here, this is categorical, categorical, and categorical. Okay, so in this case, I can do one at a time, or I can just use a for loop. So in this case, I'm choosing to use a for loop. I'm iterating through each one of the columns, and I'm actually doing box plot for each one of them. Okay, so when I run this, it gives me mpg by origin. This part we just did this a minute ago. So this is mpg by cylinder. So let me decrease the size of the screen so it's a little bit more visible. All right, so you can see that for mpg by cylinder, it seems like three cylinder car, they have a low mpg, and your eight cylinder, they definitely have a very low mpg, but the four cylinder, they are giving you high mpg. You can see that the mpg for four cylinder is ranging from 25 to maybe 33, 34. So for four cylinder is giving you high mpg. Okay, let's look at the mpg by model year. So in this case, you can see that as the year goes, as the years have been increasing, your mpg has been kind of like going up a little bit steadily. Okay, it has been kind of going up. That's good. All right, then so the observation is this. Let me increase the size of the screen. So the mpg is highest when cylinder equal to 4. We saw that. Mpg is lowest when cylinder equal to 8. We also saw that. And mpg versus model year, we see that the mpg has gone up with years. And now let's try to find the trend using line plot. So in this particular instance, I'm actually doing my group by model year and MPG. So in this case, I'm focusing on MPG versus model year. This is my numerical, this is categorical. So in this case, I'm using line plot. My X is model year and my Y is going to be MPG, and my data is going to be equal to yearly trend. That would be this right here. Okay, and then I plot there. So in this case, you can see that average MPG trend over model years. Let me just decrease the size of screen so it's a little bit more visible. All right. So you can see that as the model year has been going up, as the year has been progressing, your average MPG has been kind of like going up. Okay, so it has like it goes up, then it went down, then it went up, 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 then it went down at this place, then it has been going up ever since. Then there was a small drop over here, right here. Okay, so in this case, it tells me that the average MPG has an increasing trend over the years. Now let's add some more info on the trend over the years. So what I'm doing, I'm just adding another scatter plot over here on the same graph. So I'm adding this line, and when I plot this, it actually gives me MPG by model year. So in this case, you can see that trend basically is the same as the one on the top, but now you're able to see the points. And each one of these points, they correspond to data points. So you can see that your data points, okay, so these are your data points right here. Each circle, these are your data points. Okay, so each point is a car, and the red line is an average MPG trend. This one is right here is the average MPG trend. So this is another alternative that you can use if you want to see your trend with your points labeled on your graph. And now you can also use violent plot. In this case, you can use violent plot for distribution and for also density. So in this case, I'm going to use origin versus MPG. In this case, origin is my categorical, and this one right here is numerical. So you call Seaborn's library violent plot, specify your X equal to column, which is origin, and my Y equal to MPG. So when I plot this, you can see that MPG by origin. Let me decrease the size of the screen. All right. So this is MPG distribution by origin. Let me decrease some more. Okay, so you can see that USA cars, their most of their MPG, it's ranges from, let's say, 11 to maybe over here. This is where most of the data lies. Okay, for USA car. For cars that are in Japan, most of the data or most of the MPG is basically in this region right here. For European cars, most of your data is between here to here. So this is basically a range right here. So from here you can determine your range. So you can see that the MPG for USA car is kind of significantly lower. But on the other hand, the MPG for your Japanese car is a little bit higher. The MPG for Japanese car is doing, it gives you better result. So Japan cars, they have a better MPG. That's your observation. And for USA, most cars have MPG between 13 to 25. That's just a guesstimate based on these pictures. And now let's do the swarm plot. So in this case, I'm doing swarm plot between origin versus MPG. So you call Seaborn swarm plot library. And when I run this, you can see that this is your swarm plot. So each one of these circles, each one of these points, they represents data points. You can see that you have more circular points over here and less and less. So that tells me that this particular USA has more data right here. Also, you can see that the most of your cars in USA, their miles per gallon falls in this region right here. Most of the data is in this region. So that tells me the miles per gallon for USA is a little bit low compared with your Japan and your Europe. Your Japanese car, most of their data is in this region right here. So that tells me Japanese car, they have a better MPG, miles per gallon. Okay. So the observation is this, that more data comes from the US cars, and MPG is low for US cars and high for Japan cars. And now let's look at the grouped statistics using group by. So in this case, I'm using origin versus MPG right here. I'm calculating the mean value. So I print my group mean, and this way it gives me the group mean. So for European cars, the average, the mean value for MPG is 27.89. For Japanese car, the mean MPG is 30.45, and for USA is this. You can see that just by looking at this data, the Japanese car, they have a better MPG than US. US actually has the lowest one. We can also perform multiple statistics at once. So in this particular instance, I can do like I'm doing the same thing, except now I'm just calculating mean. I'm also calculating median, minimum, maximum, standard deviation, and the count. And you print everything out right here. So when I print values out, it prints me this data right here. So let's look at one of these values so you have an understanding of what it means. Let's look at this one right here. So this is telling me for the Japan car, the median miles per gallon is 31.6. Let's look at this one right here. Let's just analyze this one. This is telling me that your minimum MPG for European cars is 16.2. The minimum MPG for Japanese car is 18.0. The minimum MPG for US car is 9.0. So by looking at this, you can read your mean, median, and minimum, maximum, standard deviation, and count for each one of these origin for Europe, Japan, and USA. You can also describe the numerical variable grouped by category. So in this case, I'm doing the same one, origin versus MPG. So print df.group by, and at the end you say describe. So that's going to give you the key summary statistics. So when I run this, it gives me the key one. So let's look at one of these values. So in this case, it's telling me that these data, right? Let's look at this one. This is telling me that 25 percentile for European cars is 24. In other words, 25% of your data for MPG, it lies for the European car is below 24. That's what it means. This is 25th percentile for your Japanese car. This one is 25th percentile for US cars. This one right here is 50th percentile for Japanese car. In other words, 50% of your data has the value MPG less than 31.6 for Japanese car. That's what you mean by these values. Now let's do bar plot with 95% confidence interval on the mean value. So in this case, I'm specifying my figure size first thing, then I'm also doing bar plot and I'm plotting my data equal to DF, my X equal to origin, and my Y equal to MPG. That's what I'm doing. My categorical versus numerical right here. In this case, I specify my estimator equal to mean. When I plot this thing, and let me just decrease the size of the screen. All right, when I plot this thing, it gives you the average MPG by origin. And you can see that Japanese car, they have a higher average MPG, and your US car has a least one. Also, you see this vertical line right here. This gives you the 95% confidence interval. It tells you basically 95% chance that your mean is going to be lying between this range to this range right here. For your Japanese car. For your European car, it's 95% chance that your data is going to be lying, your mean value is going to be lying between this to this. That's what you mean by this.